Take a look for seat point 2, equilibrium constant. For learning outcome, at the end of the lesson, students should be able to define homogeneous and heterogeneous equilibria, write expression for equilibrium constant in the term of concentration Kc, partial pressure Kp for both homogeneous and heterogeneous system, define the degree of dissociation, and write the expression for reaction quotient or symbol by Q. So right now we take a look for AB first, okay, for our discussion. Alright, homogeneous and heterogeneous, we have the clue, the term same phase or different phase, which is homogeneous equilibrium mentioned product reactant are in the same phase. Heterogeneous equilibrium mention the product and reactant more than one phase or different phase, such as for first one, homogeneous equilibrium, take a look at the first equation. N2O4 gases decompose, produce reversible reaction, right? To produce 2NO2. And same one goes to SO2, 2SO2. React with oxygen, decompose to SO3. We have reversible reaction also. And example for heterogeneous equilibrium. Okay, take a look. CaCO3 solid, produce CaO solid and CO2 gas. Alright, and equation number 3, actually hydrogen gases, bromine liquid decompose, produce 2HBr. So we can observe we have a different phase, maybe solid, gas, liquid. Okay, take a look there. Example given. Okay, for both homogeneous equilibria, heterogeneous equilibria, we have relationship that we call Kc. So the next one, we try to write Kc expression that we relate by mass law, okay, for equilibrium. Alright. Example for the general, A, B decompose, produce C and D. Okay, Kc, the equilibrium equal to concentration of C and D over A and B, which is A, B, C, D. Consider the coefficient, stoichiometry, balance equation. Alright, okay. So, for the example, N2O4 gases decompose, produce 2NO2 gas. So, we can highlight directly product, the concentration product over reactant. So, the coefficient stoichiometry, we can consider the repeating amount of the concentration, power of 2. We have 2 mole. Alright, okay. Next one, just write the expression, right? Okay, no need to proceed calculation right now. We just the first step, write the expression in this one, the term Kc. Okay, alright, the second example we have, okay, CH3COOH produce ethanol ion and hydrogen ion aqueous. So take a look, aqueous. We can highlight the homogeneous sample lah, homogeneous that we called before, homogeneous equilibrium. Okay, alright. So for Kp also, okay, if you take a look example given for Kp expression, we call Kp expression, okay, which is, okay, the general, okay, what the difference between Kc and Kp, the bracket, subscript the bracket we use, alright. So Kp, partial pressure of C, partial pressure of D, which is the product over reactant, partial pressure of A, partial pressure of B, and consider the coefficients stoichiometry for the balance equation. Right, so based on example, gas N2O4 produce gases NO2, same phase. So directly expression for Kp, partial pressure NO2 over partial pressure of N2O4, which is considered by 2 mole. We have 2 coefficient for NO2 multiply ataupun we have power of 2. Okay, so for next nitrogen and hydrogen decompose, produce ammonia, reversible reaction. We have partial pressure ammonia, okay, power of 2, alright, divide by nitrogen and hydrogen. Okay, the unit of pressure atmosphere. Before the unit of Kc actually molar, we have mole per liter. Okay, alright, and this one the keep in mind, actually the reminder. Okay, the equation of value Kp Kc must be specific balance equation. Okay, and then consider the phase also. Alright, so for example, okay, so we have Kc and Kp actually. Okay, so what happened? Balance the equation first. Okay, so this one try to take a look reactant product and element for both side, left and right. Okay, so you can proceed the balance equation. Okay, take a look for our heterogeneous equilibrium. Have a keyword. Okay, take a look here. We have a different phase. Alright, so basically, if you consider by Kc expression, okay, alright, we have CO2 CaO divide by CaCO3, basically. But right now, actually, CaO for product, CaCO3 are constant because solid, which is the concentration of pure solid, pure liquid, solvent, do not appear in equilibrium constant expression. So, once we reject solid, just proceed Kc equal to CO2 or Kp equal to partial pressure P CO2. Alright, so as the first step, balance the equation first. After you balance the equation, consider the phase. Is it solid? Is it pure liquid? Okay, and then just reject the constant value. Okay, find out the next expression according, depends Kc or Kp. Alright, this one example. If you try to show the example, okay, what happened to the pure solid? Okay, just the same density, any temperature. Okay, same reason apply to pure liquid. Okay, example, no need, I need to discuss here. Okay, you can take a look actually. Can identify. Okay, right, Kc and Kp. Okay, take a look at the next one. Alright, relation between Kp, Kc. In this case, what happened? If data Kp given, you want to calculate Kc, or Kc given, you want to calculate Kp. We use the formula that we call Kp, Kc, RT, delta N. Okay, so delta N equal to what? The total number of product, number of mole, number of mole of product, the difference between total number mole of reactant. Okay, that one delta N. Okay.